Hey there, science fans! Today, we're diving into the exciting world of electrovalent bonds. These bonds are the glue that holds together many substances we encounter every day. From the salt we sprinkle on our food to the batteries that power our devices, electrovalent bonds are everywhere. Ever wondered how these bonds work? Get ready to unlock the secrets of these fascinating forces of attraction. Let's get started. Before we can understand electrovalent bonds, we need to talk about atoms. Atoms are like tiny building blocks that make up everything around us. They're incredibly small, even smaller than you can imagine. Each atom has a central part called the nucleus, which contains positively charged particles called protons, and neutral particles called neutrons. Whizzing around the nucleus are negatively charged particles called electrons. Now let's see how these atoms get charged up and ready to bond. Atoms like to have a balanced number of protons and electrons. This balance is crucial because it determines the atom's overall charge. Protons, which are positively charged, and electrons, which are negatively charged, usually exist in equal numbers in a neutral atom. This equilibrium makes the atom stable and content. It makes them stable and happy. When atoms are in this balanced state, they are less likely to react with other atoms. This stability is what every atom strives for, as it means they have achieved a state of minimal energy and maximum stability. But sometimes, atoms lose or gain electrons. This can happen due to various reasons, such as chemical reactions, exposure to radiation, or even collisions with other particles. When an atom loses an electron, it becomes positively charged, and when it gains an electron, it becomes negatively charged. When this happens, they become ions. Ions are simply atoms or molecules that have a net electrical charge. This charge imbalance makes ions highly reactive, as they seek to regain stability by either losing or gaining electrons to return to a neutral state. Think of it like this. Imagine an atom is like a basketball team with 5 players. Each player represents an electron. The team is balanced and ready to play when all 5 players are on the court. If one player leaves, the team is short-handed and has a negative charge. This is similar to an atom losing an electron. The atom now has more protons than electrons, giving it a positive charge. That's like an atom gaining an electron and becoming a negative ion. In this case, the atom has more electrons than protons, resulting in a negative charge. This imbalance makes the atom eager to lose the extra electron to return to a neutral state. Now, if the team gets an extra player, they have a positive charge. Similarly, if an atom gains an extra electron, it becomes negatively charged. This extra electron makes the atom unstable, and it will seek to lose the electron to regain its balance. That's like an atom losing an electron and becoming a positive ion. This positive ion, or cation, is now highly reactive and will seek out negatively charged ions or anions to bond with and achieve stability. These charged atoms are ready to form electrovalent bonds. Electrovalent bonds, also known as ionic bonds, occur when oppositely charged ions attract each other and form a stable compound. This type of bonding is essential in the formation of many everyday substances, such as table salt. Understanding how ions form and bond is crucial in the study of chemistry and helps us comprehend the behavior of different materials. Section 4, Opposites Attract, the electrovalent bond. You know the saying opposites attract? Well, it's true for ions too. In the world of chemistry, this principle is fundamental to the formation of electrovalent bonds, also known as ionic bonds. These bonds are the result of the electrostatic attraction between positively charged ions, called cations, and negatively charged ions, known as anions. This type of bonding is crucial in the formation of many compounds, including common table salt. Positive and negative ions attract each other just like the opposite poles of a magnet. When a metal reacts with a non-metal, the metal atom loses electrons to form a positively charged ion, while the non-metal gains those electrons to form a negatively charged ion. This transfer of electrons creates a strong electrostatic force that pulls the ions together. This attraction forms a strong bond called an electrovalent bond. These bonds are incredibly strong due to the significant difference in electronegativity between the participating atoms. The resulting compounds often have high melting and boiling points because a lot of energy is required to break the strong electrovalent bonds. Imagine trying to hold 2 powerful magnets with the same poles together. They resist each other and push away, demonstrating the repulsive force between like charges. They push each other away, right? This is similar to how like-charged ions repel each other in a solution, preventing them from coming together. But if you flip one magnet, they stick together tightly. This is because opposite charges attract, creating a strong bond between them. That's similar to how electrovalent bonds work. When ions of opposite charges come into proximity, they attract each other and form a stable structure. This is a fundamental concept in chemistry that explains the formation of many ionic compounds. This electrostatic force between the oppositely charged ions is what holds them together in a crystal lattice structure. In a crystal lattice, each ion is surrounded by ions of the opposite charge, creating a repeating pattern that extends in all directions. This strong attraction is what makes electrovalent bonds so powerful. The stability and strength of these bonds are why ionic compounds are often hard and brittle, and why they can conduct electricity when melted or dissolved in water. Understanding electrovalent bonds is key to grasping the behavior of many substances in chemistry. Section 5. Electrovalent bonds in action. Real-world examples. Electrovalent bonds are everywhere. Let's look at some examples. Take table salt for instance. It's made up of sodium ions, Na+, and chloride ions, Cl, held together by, you guessed it, electrovalent bonds. Another example is magnesium oxide, MgO, a compound used in medicines and high-temperature resistant materials. The magnesium ions, Mg2+, and oxide ions, O2, are held together by strong electrovalent bonds. From the medicines we take to the ceramics in our homes, electrovalent bonds play a crucial role in countless materials we use every day. Section 6. The importance of electrovalent bonds, from salt to smartphones. Electrovalent bonds are essential for life as we know it. These bonds, also known as ionic bonds, occur when atoms transfer electrons to achieve a full outer shell, creating charged ions that attract each other. This fundamental interaction is the basis for many compounds that are crucial to our daily lives. They play a vital role in many biological processes, like the transport of nutrients and nerve impulses. For instance, the sodium-potassium pump, which is essential for nerve function, relies on the movement of sodium and potassium ions across cell membranes. This process is driven by electrovalent bonds, ensuring that our nerves can transmit signals efficiently. Beyond biology, electrovalent bonds are crucial in various industries. In the chemical industry, these bonds are foundational in the creation of numerous products. From the synthesis of basic chemicals to the development of advanced materials, electrovalent bonds are at the heart of many industrial processes. They are used in making fertilizers, detergents, and other household products. Fertilizers, for example, often contain compounds like ammonium nitrate, which is formed through electrovalent bonding. These fertilizers are essential for modern agriculture, helping to feed the world's growing population, and even the lithium-ion batteries that power our smartphones. These batteries rely on the movement of lithium ions between the anode and cathode, a process that is made possible by the electrovalent bonds within the battery's electrolyte. This technology has revolutionized portable electronics, making devices more efficient and longer lasting. So, the next time you sprinkle salt on your food or use your smartphone, take a moment to appreciate the science behind these everyday actions. Salt, or sodium chloride, is a classic example of an electrovalent compound where sodium and chloride ions bond together to form the crystals we use in cooking. Remember the amazing electrovalent bonds that make it all possible. These bonds are not just a topic in chemistry textbooks, they are a vital part of the world around us, influencing everything from the food we eat to the technology we use. It's just one more example of how science makes our world so fascinating. By understanding the principles of electrovalent bonding, we gain a deeper appreciation for the intricate and interconnected nature of the universe. Science truly is the key to unlocking the mysteries of our world.